Metals are good conductors of electricity, but what actually carries the electrical charge through a metal? The answer is the delocalized electrons, not the positive metal ions. A metal has a giant metallic structure. It contains positive metal ions and delocalized electrons. The positive metal ions are packed closely together. The delocalized electrons are spread throughout the metal structure. This is the structure that allows metal to conduct electricity. The delocalized electrons are mobile. This means they are free to move through the metal. When a voltage is applied, these electrons can move through the metal in a more organized way. As they move, they carry electrical charge. That is why metals can conduct electricity. What about the positive metal ions? The positive metal ions are charged, but in a solid metal, they are fixed in position. They can vibrate about their positions, but they do not move freely through the metal. So, they are not the charge carriers in a solid metal. The mobile delocalized electrons carry the charge instead. An electric current is a flow of charge. In metals, this charge is carried by electrons. The delocalized electrons move through the metal and carry the current. This is different from ionic compounds. Ionic compounds conduct electricity only when their ions are mobile. But metals conduct because their delocalized electrons are mobile. So, the key idea is simple. Metals conduct electricity because they have mobile delocalized electrons. These electrons can move through the metal and carry charge. The positive metal ions are charged, but they are fixed in place in a solid metal. So, in metals, electrical conduction is due to mobile electrons. Remember, metals conduct electricity because delocalized electrons can move and carry charge. The positive metal ions help form the metallic structure, but in a solid metal, they do not move through the metal to carry the current.